Good morning everyone. Today we are going to see probability and queuing theory. So here is the objective: to provide the required mathematical support in real life problem and develop probabilistic model which can be used in several areas of science and engineering. So in 5 units, unit 1 referring random variable, unit 2 dimensional random variable, unit 3 random processes, unit 4 queuing model, and unit 5 is advanced queuing model. So today we are going to see about random variable, that is unit 1 discrete and continuous random variable, moments, moment generating functions, binomial, Poisson, geometric, uniform, exponential, gamma and normal distributions. In unit 1 random variables, here is the introduction of random variable. Consider an experiment of throwing a coin twice. The outcomes are head head, head tail, tail head and tail tail. Consider the sample space. Each of these outcomes can be associated with the number by specifying a rule of association. Such a rule of association is called random variables. Here we are going to see the example of a sample space. So sample space is nothing but consider an experiment of throwing a coin twice. The outcomes we know that, which should be denoted in S. So such a experiment is called sample space. Our next definition is random variables. So random variable is nothing but in the sample space, each of these outcomes can be associated with a number by specifying a rule of association. Such a rule is called a random variable. For example, I am taking the number of heads. So I am throwing a coin twice. So I get the output as head head, head tail, tail head and tail tail. In this, the number of head denoting there are 2 head here, one head and 0 number of head. So I am constituting the random variable as x of s, which equals 2, 1, 1, 0. So next we are moving to the discrete random variable definition. A discrete random variable is a random variable x whose possible value constitute finite set of values or countably infinite set of values. So discrete denoting the finite set or countably infinite set. The same example has given in the random variable definition. So next we are going to see the cumulative distribution of the random variable. So which is the definition is the distribution function of a random variable x defined in minus infinity plus infinity is given by f of x is equal to probability of capital X less than or equal to small x, which equals the probability of s such that x of s is less than or equal to s. Here are some properties given under distribution function. So first property is probability of x lies between a to b, which includes b. So formula is f of b minus f of a. Second property is probability of x lies between a to b. Then the formula is probability of x equal to a plus f of b minus f of a. Or third property is probability of x lies between a to b. So in this, x included a and b, this is excluded a and b. So the formula is probability of a less than x less than or equal to b minus probability of x equal to b, which can also be written as f of b minus f of a minus probability of x equal to b. So the next definition is probability mass function or just probability function. Let x be a one-dimensional discrete random variable which takes the values 1, x1, x2, etc. To each possible outcome xi, we can associate a number pi. So the probability is denoted as probability of x equal to xi, p of xi, which equals pi, which satisfies two conditions. So first one is probability of xi greater than or equal to 0. Our second condition is summation I is equal to 1 to infinity, probability of xi is equals 1. Okay, here is the problem given under probability function. See the example 1.2. A random variable x has the following probability function. So here are the value of x given as 0, 1, 2, etc. 8, and the probability of x is given as a, 3a, 5a up to 17a. Here we need to find the value of a, then probability of x less than 3, probability of x greater than or equal to 3, probability of x lies between 0 to 5. Then the third condition is find the distribution function of x. So we are going to see the solution for this. First of all, I am writing the table as it is in the question. So the next, we are going to find the value of a. So for that, I know the definitions of a probability mass function, summation probability of xi is equal to 1. So here I denoting 0 to 8 because we get only the up to 8 values. So I am adding all the values, that is probability of 0, probability of 1, probability of 2, etc., probability of 8, which equals 1. When I add all the values a plus 3a plus 5a plus etc. 17a, I get 81a is equal to 1. So that I can find the value of a as 1 by 81. So first condition is proved here. In the second condition, I need to prove the three things. So first of all, I am changing the given table as, so instead of a, I can substitute 1 by 81. So instead of 3a, I can write 3 by 81. Similarly, for all the things, 17a can be written as 17 by 81. So next, I am going to find probability of x less than 3. So x less than 3 is nothing but probability of 0, probability of 1, probability of 2. So the value is 1 by 81 plus 3 by 81 plus 5 by 81. If I add all the thing, I get 9 by 81. The next one, we need to find probability of x greater than or equal to 3. So which included 3 also, which means I need to add greater than or equal to 3. So 3 to 8. So which means I can substitute the formula like 1 minus probability of x less than 3. I already know the value for probability of x less than 3, that is 9 by 81. So in that subtract 1 from it. So I get 1 minus 9 by 81, which get 72 by 81. In the third one, I need to find probability of x lies between 0 to 5. So 0 value to 5 value in between. So there is no included value of 0 to 5 between 0 to 5, that which means probability of 1, 2, 3, 4. So I know the value 3 by 81, 5 by 81, 7 by 81, 9 by 81. If I add all the thing, I get the value as 24 by 81. At last, our third condition is we need to find the distribution function of x. We know the x value, which lies between 0, 1, 2, etc. 8. So first, probability of 0 is nothing but f of 0 is equal to probability of 0, that is a value 1 by 81. Next, 1 means we need to add less than or equal to 1, which included 0 and 1. So 1 by 81 plus 3 by 81, 4 by 81. So next, probability of x less than or equal to 2 means 0, 1, 2. If I add all the thing, I get 9 by 81. Similarly for 3, 4, 5, 6, 7 and 8. So f of 8 is nothing but probability of x less than or equal a, which means I need to add all the values from p of 0, p of 1, p of 2, etc. p of 8, I get 64 by 81. So that is the value of x So that I get 64 by 81 plus 17 by 81. I get 81 by 81. So the value is equals 1. So our next definition is continuous random variable. A random variable x which takes all possible values in a given interval is called continuous random variable. So we already read the definition of a discrete random variable which take only the finite value, but in continuous random variable it will take all possible values. So for example, age, height, weight are continuous random variables. So the next we are going to see the properties of probability density function. F of x greater than or equal to 0. So x lies between minus infinity to plus infinity, and another condition of probability density function is integral minus infinity to plus infinity f of x dx equals 1. So these are some important definitions given under probability distribution functions. Okay, here we are going to see the continuous distribution function. So that is, we already know the formula, integral minus infinity to plus infinity f of x dx. So that is, x lies between minus infinity to plus infinity. Here are some properties given under continuous distribution function. So that is, first definition, f of x lies between 0 to 1. So x lies between minus infinity to plus infinity. Second property is limit f of x equals 0, limit f of x equal 1 if x approaches minus infinity. Third condition is probability of x lies between a to b. Then our formula will become integral a to b f of x dx, which can also be written as f of b minus f of a. Fourth property is f dash of x, that is d f of x divided by dx, which equal f of x. Fifth condition is probability of x equal to xi, which equals f of xi minus f of xi minus 1. Now we are moving to the problem under continuous random variable. So given the probability density function of a random variable x follows, f of x equal 6x of 1 minus x. Here the x value lies between 0 to 1, otherwise the value of f of x equals 0. We need to find the continuous distribution function for x. We already know the formula for continuous distribution function, so which is f of x is equal to minus infinity to plus infinity f of x dx. But here they have given the value under x, so I am taking the integral lies between minus infinity to x f of x dx. Our first one, we need to find probability of x less than 0, which takes the value from minus infinity to x f of x dx. So minus infinity f of x value is 0 as given in the question. So I can substitute 0 dx, which equals 0. Second one, to find the continuous distribution function, I need to substitute the value between x lies between 0 to 1, which means my integral is changing into 2. So one is minus infinity to 0, the next one is 0 to x. We already know that minus infinity takes the value as 0. Here 0 to x denoting f of x. So x lies between 0 to 1. So our f of x value is 6x into 1 minus x. I am substituting it. 6 is a constant, take it out. So the remaining value is integral 0 to x of 1 minus x dx. So here I am multiplying x inside the bracket. So I get x minus x square into dx. If I integrating this value with respect to 0 to x, I get, so the value of x is nothing but x square by 2, and the value of x square is x cube by 3 with the limit 0 to x. So I am substituting for upper integral, I get the same value, so which is nothing but x square by 2 minus x cube by 3. If I substitute lower integral, I get the same value as 0. As already 6 is the constant which is outside the bracket, so if I take the LCM for both the thing, I get 6 times of 3x square minus 2x square. The outer box 6 is there. I can cancel 6 each other. So the remaining value is, so this is x cube. So 3x square minus 2x cube, which is the value I get the here. The next one, third condition, I need to find probability of when x is greater than 1, then our integral will become f of x is equal to integral minus infinity to x f of x dx. So x is greater than 1, which means my integral value is taken between minus infinity to 0, 0 to 1 and 0 to x. I already know the value of minus infinity takes 0, 0 to 1 and so here the 0 to x also taken the value for as 0. So the remaining value is integral 0 to 1 6x of 1 minus x. The same thing I am going to continue here. So that is take the 6 as a constant. Next the remaining will be x in minus x square. If I integrate it, I get x square by 2 minus x cube by 3. Take the LCM, so I get 6 times of 3x square minus 2x cube. So with the limit 0 to 1, see here our integral is lies between 0 to 1. 6 is cancel each other, so that I get 3x square minus 2x cube. If I substitute the value of 1, I get 3 minus 2, which equals 1, because the lower limit is 0, so no need to supply. Here I find the 3 values using continuous distribution function. First one is if x value is less than 0, I find it as 0. Next, if x value lies between 0 to 1, I found 3x square minus 2x cube. If the x value is greater than 1, I find the value as 1. This is how we can find the value of continuous distribution function. Here is one more example given under continuous distribution function, that is f of x is equal to e power minus x. If the value of e power minus x is positive, it will take f of x is greater than or equal to 0. The next one, minus infinity to plus infinity, f of x dx equal to minus infinity to 0 f of x dx plus 0 to infinity f of x dx. We already know that the minus infinity takes the 0 value, and this value 0 to infinity, which takes the f of x as e power minus x with the limit 0 to infinity. If I substitute the upper limit, I get minus e power minus infinity minus, if I substitute the lower limit, I get e power 0. So the value is 1. There is minus already in the inside the bracket, and formula minus is there, so it will be plus 1. So e power minus infinity value is nothing but 0. So I am remaining with value as 1. The next is second condition. They are asking to determine the probability that the variate having this density will fall in the interval 1 to 2. For that, I am taking the value of probability of x lies between a to b, which means our formula is f of x dx in the integral a to b. If the x value lies between 1 to t, then the integral lies between 1 to 2 f of x dx. So now 1 to 2, the value of f of x is nothing but e power minus x dx. Substitute the upper limit and the lower limit, so that I get minus e power minus 2 plus e power minus 1. Then the value of e power minus 2 is nothing but 0.135, that is negative before the values, and also e power minus 1 value is nothing but 0.368. If I add both the thing, I will get the value 0.233. So in the question they have asked to find determine the probability that the variate having this density will fall in the interval 1 to 2. That's how I find it here. So the value lies between 1 to 2 is nothing but 0.233. This is how we can find the value of continuous distribution function using the formula integral f of x dx. The next topic is discrete distribution. So there are three distributions. The first one is binomial distribution, second one is Poisson distribution, and third one is geometric distribution. Now we are going to see the binomial distribution. Here is the definition of binomial distribution. A random variable x is said to follow binomial distribution if its probability law is given by, so p of x is equal to NCX, this is p power x q power n minus x. So this is the formula for binomial distribution. So that is probability of x is equal to NCX p power x q power n minus x. So this is formula for binomial distribution. So now we are going to see, find the moment generating function of a binomial distribution. So moment generating function, the normal formula is mx of t is equal to summation x equal to 0 to n e power tx into p of x. So I am taking this value as e power capital E of e power tx. So that is summation x equal to 0 to n e power tx into p of x. Here p of x denoting the binomial distribution. We already know the formula for binomial distribution, which is p power ncx p power x q power n minus x. In this p power x and e power tx, there is x common on both the power. So I am taking the power p e power t the whole power x into the remaining term ncx q power n minus x. So mx of t is equal q plus p e power t the whole power n. So which can be referred as moment generating function of binomial distribution, which is q plus p e power t the whole power n. Next we are going to see mean and variance of binomial distribution. So we know the moment generating function of a binomial distribution. So the formula is mx of t is equal to q plus p e power t the whole power n. If I differentiate it to one time, I get n q plus p e power t the whole power n minus 1 into p e power t, because it is differentiating with respect to t, so that I get p e power t outside. If I substitute t equal to 0, here e power 0 will become 1, this also will become 1. So the remaining term is n of q plus p the whole power n minus 1 into p. So the mean value is, the formula is e of x. So the value of q plus p is 1, so that I get n into p. So the mean value is e of x equal to np. Next we need to find the variance of binomial distribution. For that I need to differentiate m x dash of t one more time, that is mx double dash of t, so that I get the value. So using UV method, np of q plus p e power t the whole power n minus 1 into e power t plus e power t n minus 1 q plus p e power t n minus 2 into p e power t. Similarly, we need to substitute t equals 0. So the value of e power t, all the e power t will become 1. So I will remain with np q plus p the whole power n minus 1 plus n minus 1 q plus p the whole power n minus 2 into p. Here I am denoting the q plus p value as 1. So both the value will become 1. So I will remain with np of 1 plus n minus 1 into p. Now substitute this np inside the bracket. So I get np plus n square p square minus np square. So in this I am taking np as common in both the thing. So I get n square p square plus np of 1 minus p. We already know the formula for 1 minus p is nothing but q. So I am substituting the 1 minus p value as q. So m x double dash of 0 equal n square p square plus n p q. So I am taking this value as e x square. We need to find the variance value. The formula for the variance is e of x square minus e of x the whole square. So e of x square value is nothing but n square p square plus np cube, and the e of x value is the mean value, that is np. This is whole square, which means n square into p square. This positive value and negative value cancel out each other. So I am remaining with the variance value as np. So here the mean value of binomial distribution is np and the variance value of binomial distribution is npq. So here some problem given under binomial distribution. Check whether the following binomial distribution is a binomial distribution or not. They have given the mean value as 3 and the variance value as 4. They are asking us to find whether the given term is binomial or not. So for that I know the value for the mean, which is nothing but np, that is equal 3, which is given in the question, and the variance formula is npq, which equals 4. So here I need to find the binomial distribution, so I am dividing 2 by 1. So that is np divided by npq, which is 3 by 4. I am remaining with 1 by q is equal to 3 by 4. So the q value is 4 by 3, which can be also written as 1 into 1 by 3, which value is greater than 1. So that I can easily say that the given data not follow binomial distribution because q value should greater than 1. So let's move on to the next problem. The mean and standard deviation of binomial distributions are 5 and 2. So the mean value is 5, so mean np equal to 5. We know the variance formula is npq, but the standard distribution formula is square root of npq. The value is 2. Next we are going to divide 2 by 1, so that I get n square root npq is equal to divided by np is equal to see here, square root of npq divided by np is equals 2 by 5. So I am taking the square root and solving, I get q value as 4 by 5. So p value is nothing but 1 minus q. So the q value is 4 by y. If I solve it, I get 1 by 5 as p value. Substitute 3 into 1. So that is 3 value into first equation. So here they have given the np value as 5. Here I find the p value as 1 by 5. So n into 1 by 5 equal 5. So the n value is 25. The binomial distribution, we know the formula for the binomial distribution, ncx p power x q power n minus x. N value is nothing but 25 cx. Next p value is 1 by 5 the whole power x. Next q value is 4 by 5 the whole power n minus x. So the x takes the values from 0, 1 to etc. 25 because our n value is 25. So the finite value of binomial distribution has followed by this. Next we are going to see the definition of Poisson distribution. The random variable x is said to follow if its probability law is given by p of x is equal to e power minus lambda power x by x factorial. So this is the formula for binomial distribution, e power minus lambda power x by x factorial. Here x takes the values from 0, 1, 2 etc. infinity. So limiting case of binomial distribution under the following conditions and assumptions are given. So to find the moment generating function of Poisson distribution, so see here mx of t is equal to e power tx. So that it can be written as summation x equal to 0 to infinity e power tx p of x. So p of x is nothing but the Poisson distribution of moment generating function, that is p power e power x lambda power x divided by x factorial. Substitute it and take the e power minus lambda value out. So that I will remain with summation x equal to 0 to infinity lambda e power t the whole power x by x factorial. If I expand the summation value, I get 1 plus lambda e power t by 1 factorial plus lambda e power t the whole square by 2 factorial plus etc. So this term can be written as e power lambda e power t. In both the term I can take e power lambda as constant. So the remaining term is e power t minus 1. So the moment generating function of Poisson distribution is e power lambda of e power t minus 1. Next we are going to see the mean and variance of Poisson distribution. So we know the moment generation function of Poisson distribution is e power lambda of e power t minus 1. Here to find the mean value, so differentiate m x dash of t equal to, so this is e power lambda e power t minus 1 into e power t. If I substitute the t value as 0, this both the value will become 1. So I will remain with the e power minus lambda. So the next e of x, that is the mean value. Formula is summation x equal to 0 to infinity x into p of x. P of x is Poisson distribution. Formula is e power minus lambda, lambda power x by x factorial. So next if I expand x as lambda into lambda x power n minus 1. If I substitute the value 0, I get the 0 value. So the limit changes from 1 to infinity. Next I can take lambda e power minus x's commonly out because they are constant. So I will remain with the lambda power x minus 1 divided by x minus 1. If I expand from 1 to etc infinity, I get 1 plus lambda square by 2 factorial plus lambda cube by 3 factorial plus etc. So this can be written as e power plus lambda. There is already e power minus lambda outside. Both cancel out each other. So the mean value of Poisson distribution is lambda. Next we are going to see the variance of Poisson distribution. Similarly, we need to find e of x square for Poisson distribution. Then substitute in the formula e of x square minus e of x the whole square. So e of x square, the formula is summation x equal to 0 to infinity x minus 1 plus x into p of x. The p of x is nothing but the Poisson distribution. So I will substitute e power minus lambda power x by x factorial. If I expand the summation limit and substitute all the value, so I will remain with lambda square plus lambda. Now I am moving on to the formula e of x square is lambda square plus x minus e of x the whole square, that is the mean value of Poisson is lambda, so that is square, so lambda square plus lambda square and minus lambda square cancel out each other. So I will get the value of variance of Poisson distribution as lambda. So here in Poisson distribution both the mean and variance values are equal, which is equal to lambda. Here is a note given under Poisson distribution, that is sum of independent of Poisson variate is also a Poisson variate. Next we are moving to the problem. So the first problem is, if x is a Poisson variate such that p of x is equal to 1 equal 3 by 10 and p of x equal to 2 equal 1 by 5, we need to find the value of x equal to 0 and the probability of x equal to 3. So here they have given as Poisson variate. So we know the formula for Poisson variable e power minus lambda power x by x factorial. So in this I am going to substitute p of x equal to 1, which is x takes the values 1. So lambda power x, that is lambda power 1 by 1 factorial. So I will remain with e power minus lambda into lambda equals 3 by 2, which is given in the question. So I easily write lambda e power minus lambda is equal to 3 by 10. Our second value is probability of x is equal to x minus 2 equal e power minus lambda square by 2 factorial which I'll remind the value as 1 by 5. So that is e power minus lambda square by 2 factorial 1 by 5 which is in the question. So I get this value. If I bring this 2 to the next side, I'd get e power minus lambda square is equals 2 by 5. So here they have written, so e power minus lambda equal 3 by 10, this value which is marked as the third equation, and the next value this taking 2 to the next side, I get 2 by 5, that is e power minus lambda square equal to 2 by 5. Now I am dividing 3 by 5, I get e power minus lambda into lambda divided by e power minus lambda into lambda square, which equals 3 by 10 divided by 2 by 5. So 1 5 is 5, 2 5s are 10. Bring this 2 to the down so that I get the value as 3 by 4. Here e power minus lambda and minus lambda cancel out each other, and 1 lambda cancel. So I will remain with 1 by lambda. So the value of 1 by lambda is 3 by 4. If I want the lambda value, we need to take the reciprocal, that is 4 by lambda. Here I find the value of lambda using the given term x equal to 1 and x equal to 2. Now we are going to find probability of x equal to 0, which means instead of x we are substituting 0 here. So anything power 0 value is 1. So I will remain with e power minus lambda. So lambda value is 4 by 3, that is e power minus 4 by 3. The second thing we need to find is probability of x equal to 3. Instead of x, I am substituting 3 above and below. So instead of lambda, we know the value 4 by 3. So e power minus 4 by 3 into 4 by 3 the whole cube divided by 3 factorial. So this is how we can find the Poisson variate using the Poisson distribution formula. We are moving to the next sum, which is also an important sum. So if x is a Poisson variate, probability of x equals to equal 9 p of x equal to 4 plus 90 p of x equal to 6. Here we need to find the mean and variance value for this Poisson distribution. First we know the formula for the Poisson distribution. P of x equal to x equal e power minus lambda power x by x factorial. Now I am writing the given equation. Here I am substituting the Poisson distribution. If x is equal to 2, substitute 2 factorial. X equal to 4 means lambda power 4 by 4 factorial. X equal to 6 means 6 by 6 factorial. So the remaining 90 value remains as it is. In the both terms, that is left hand side and right hand side, I can take e power minus lambda square as common. So I will remain with 1 by 2 in the left hand side, and the right hand side I am taking e power minus lambda square as common. So I will remain with 9 lambda square by 4 factorial, because lambda square taken out, lambda square into lambda square is lambda power 4. The next 90, already I take the lambda square out, so I will remain with lambda power 4 divided by 6 factorial. So this is 4 factorial. Now I am cancelling both the left hand side and right hand side. So I will remain with the value 1 by 2, 9 lambda square by 4 factorial plus 90 lambda power 4 by 6 factorial. So in this 4 factorial can be written as 4 times 3 times 2, 9 lambda square. So 3 times can cancel out each other. So it will be 3 lambda square by 4 times 2 is 8. So that is 3 lambda square by 8. Next 90 lambda power 4 divided by 6 factorial, that is 6 times, 5 times, 4 times, 3 times 2. If I cancel out 5 2s are 10. So this is 9 times. 1 times 3 is 3 times 3. So again 1 3 is 3, 2 3s are 6. So 2 4s are 8. So lambda power 4. Lambda power 4 by 8. So I can take 1 by 2 as common. I get 1 by 2 of 3 lambda square by 4 plus lambda power 4 by 4. So there is 1 by 2 in our left hand side. Cancel both the 1 by 2. So I will remain with the values lambda power 4 plus 3 lambda square minus 4 equals 0. If I take the factorization, I get lambda square equal 1. That is lambda equal plus or minus 1, and also lambda square equals minus 4 lambda value. So that I will remain with summation x equal to 0 to infinity lambda e power t the whole power x by x factorial. If I expand the summation value, I get 1 plus lambda e power t by 1 factorial plus lambda e power t the whole square by 2 factorial plus etc. So this term can be written as e power lambda e power t. In both the term, I can take e power lambda as constant. So the remaining term is e power t minus 1. So the moment generating function of Poisson distribution is e power lambda of e power t minus 1. Next we are going to see the mean and variance of Poisson distribution. So we know the moment generation function of Poisson distribution is e power lambda of e power t minus 1. Here to find the mean value, so differentiate m x dash of t equal to, so this is e power lambda e power t minus 1 into e power t. If I substitute the t value as 0, this both the value will become 1. So I will remain with the e power minus lambda. So the next e of x, that is the mean value. Formula is summation x equal to 0 to infinity x into p of x. P of x is Poisson distribution. Formula is e power minus lambda, lambda power x by x factorial. So next, if I expand x as lambda into lambda x power n minus 1. If I substitute the value 0, I get the 0 value. So the limit changes from 1 to infinity. Next, I can take lambda e power minus x's commonly out because they are constant. So I will remain with the lambda power x minus 1 divided by x minus 1. If I expand from 1 to etc. infinity, I get 1 plus lambda square by 2 factorial plus lambda cube by 3 factorial plus etc. So this can be written as e power plus lambda. There is already e power minus lambda outside. Both cancel out each other. So the mean value of Poisson distribution is lambda. Next we are going to see the variance of Poisson distribution. Similarly, we need to find e of x square for Poisson distribution, then substitute in the formula e of x square minus e of x the whole square. So e of x square, the formula is summation x equal to 0 to infinity x minus 1 plus x into p of x. The p of x is nothing but the Poisson distribution. So I will substitute e power minus lambda power x by x factorial. If I expand the summation limit and substitute all the value, so I will remain with lambda square plus lambda. Now I am moving on to the formula. E of x square is lambda square plus x minus e of x the whole square, that is the mean value of Poisson is lambda, so that is square, so lambda square plus lambda square and minus lambda square cancel out each other. So I will get the value of variance of Poisson distribution as lambda. So here in Poisson distribution, both the mean and the variance values are equal, which is equal to lambda. Here is a note given under Poisson distribution, that is sum of independent of Poisson variate is also a Poisson variate. Next we are moving to the problem. So the first problem is, if x is a Poisson variate such that p of x is equal to 1 equal 3 by 10 and p of x equal to 2 equal 1 by 5, we need to find the value of x equal to 0 and the probability of x equal to 3. So here they have given as Poisson variate. So we know the formula for Poisson variable e power minus lambda power x by x factorial. So in this I am going to substitute p of x equal to 1, which is x takes the values 1. So lambda power x, that is lambda power 1 by 1 factorial. So I will remain with e power minus lambda into lambda equals 3 by 2, which is given in the question. So I easily write lambda e power minus lambda is equal to 3 by 10. our second value is probability of x is equal to x minus 2 equal e power minus lambda square by 2 factorial, which I will remind the value as 1 by 5. So that is e power minus lambda square by 2 factorial 1 by 5 which is in the question. So I get this value. If I bring this 2 to the next side, I would get e power minus lambda square is equals 2 by 5. So here they have written, so e power minus lambda equal 3 by 10, this value which is marked as the third equation, and the next value this taking 2 to the next side, I get 2 by 5, that is e power minus lambda square equal to 2 by 5. Now I am dividing 3 by 5, I get e power minus lambda into lambda divided by e power minus lambda into lambda square, which equals 3 by 10 divided by 2 by 5. So 1 5 is 5, 2 5s are 10. Bring this 2 to the down so that I get the value as 3 by 4. Here e power minus lambda and minus lambda cancel out each other, and 1 lambda cancel. So I will remain with 1 by lambda. So the value of 1 by lambda is 3 by 4. If I want the lambda value, we need to take the reciprocal, that is 4 by lambda. Here I find the value of lambda using the given term x equal to 1 and x equal to 2. Now we are going to find probability of x equal to 0, which means instead of x we are substituting 0 here. So anything power 0 value is 1. So I will remain with e power minus lambda. So lambda value is 4 by 3, that is e power minus 4 by 3. The second thing we need to find is probability of x equal to 3. Instead of x, I am substituting 3 above and below. So instead of lambda, we know the value 4 by 3. So e power minus 4 by 3 into 4 by 3 the whole cube divided by 3 factorial. So this is how we can find the Poisson variate using the Poisson distribution formula. We are moving to the next sum, which is also an important sum. So if x is a Poisson variate, probability of x equals to equal 9 p of x equal to 4 plus 90 p of x equal to 6. Here we need to find the mean and variance value for this Poisson distribution. First we know the formula for the Poisson distribution. P of x equal to x equal e power minus lambda power x by x factorial. Now I am writing the given equation. Here I am substituting the Poisson distribution. If x is equal to 2, substitute 2 factorial. X equal to 4 means lambda power 4 by 4 factorial. X equal to 6 means 6 by 6 factorial. So the remaining 90 value remains as it is. In the both terms, that is left hand side and right hand side, I can take e power minus lambda square as common. So I will remain with 1 by 2 in the left hand side, and the right hand side I am taking e power minus lambda square as common. So I will remain with 9 lambda square by 4 factorial, because lambda square taken out, lambda square into lambda square is lambda power 4. The next 90, already I take the lambda square out, so I will remain with lambda power 4 divided by 6 factorial. So this is 4 factorial. Now I am cancelling both the left hand side and right hand side. So I will remain with the value 1 by 2, 9 lambda square by 4 factorial plus 90 lambda power 4 by 6 factorial. So in this 4 factorial can be written as 4 times 3 times 2, 9 lambda square. So 3 times can cancel out each other. So it will be 3 lambda square by 4 times 2 is 8. So that is 3 lambda square by 8. Next 90 lambda power 4 divided by 6 factorial, that is 6 times, 5 times, 4 times, 3 times 2. If I cancel out 5 2s are 10. So this is 9 times. 1 times 3 is 3 times 3. So again 1 3 is 3, 2 3s are 6. So 2 4s are 8. So lambda power 4. Lambda power 4 by 8. So I can take 1 by 2 as common. I get 1 by 2 of 3 lambda square by 4 plus lambda power 4 by 4. So there is 1 by 2 in our left hand side. Cancel both the 1 by 2. So I will remain with the values lambda power 4 plus 3 lambda square minus 4 equals 0. If I take the factorization, I get lambda square equal 1. That is lambda equal plus or minus 1, and also lambda square equals minus 4 lambda value. In unit 3 of probability and stochastic model, we are going to see random process. Here is the introduction. Generally signals are classified into two types. One is deterministic and another one is random process. So here the definition of random process is, a random process is a collection of random variables. Here it is denoted as x of s comma t, that are f x y of a real variable, namely time t, where small x belongs to capital S and small t belongs to capital T. So classification of random process, we shall consider only 4 cases based on time t. So first one is continuous random process, next continuous random sequence. In discrete there are two types, discrete random process and discrete random sequence. Here they have given the statistical averages. We know the formula for mean is E of x of t, which is nothing but integral minus infinity to plus infinity x f of x comma t into dx. Next to find the autocorrelation, which means r x of t1 comma t2 is equals E of x1 into x of t1 into x of t2, which is denoted in the integral double integral minus infinity to plus infinity x1 of f of x1 x1 t1, next x2 f of x2 t2 dx1 dx2, or simply it can be written as r x of t1 plus t2 comma tau equal E of x of t into x of t plus tau. Now we are moving to the problem. First order strict sense stationary. So that is nothing but stationary process, the another name is strictly stationary or strict sense stationary. So random process x of t is said to be stationary in the strict sense. If its statistical characteristic do not change with the time, which means a stationary should satisfy these two formula. One is mean value and another one is variance value. So first one, E of x of t should be equal to constant and gamma x of t equals constant. So here is the first problem given as, consider the random process x of t equal cos of omega naught t plus theta, where theta is uniformly distributed in the interval minus pi to plus pi. Check whether the given process is stationary or not. Find the first and second moments of the process. So just in this question we need to find the stationary or not. Stationary means it should satisfy two conditions. We will see whether it is satisfying or not. First of all, I am taking the given value, that is x of t equal cos of omega naught t plus theta. In the question they have denoted theta is uniformly distributed in the interval minus pi to plus pi, which means f of theta take the value 1 by 2 pi. So we will substitute this in the equation. So to prove stationary, which means x of t is triple S process, mean value should equal constant and variance value should equal constant. We know the formula for variance of x of t is nothing but E of x of t plus E of x square minus E of x of t the whole square. So this is the formula for variance. Next we are going to find the first condition, that is the mean value equal to constant or not. Let's check here. So we know the formula for the mean value, integral minus infinity to plus infinity x of t into f of theta d theta. X of t is given value which is in the question. that is cos of omega naught t plus theta, and the value of f of theta is 1 by 2 pi into d theta with the integral minus pi to plus pi. I am taking this 1 by 2 pi as constant outside. So integration of sine I get, integration of cos I get sine omega naught t plus theta with the integral minus pi to plus pi. So I am substituting the upper limit and lower limit, I get this value. So this is plus pi and minus pi. So pi value, sin pi value is 0. So I will remain with minus sin omega naught t plus sin omega naught t, which will cancel each other. So the value is equal to 0. So the mean value is equal to constant. Next I need to prove the variance of x of t, that is e of x square of t minus e of x of t the whole square. We already find the value e of x of t, that is 0. We only need to find e of x square of t. So here is the formula for e of x square of t, which is nothing but integral minus infinity to plus infinity x square of t into f of theta d theta. So x square of t, I am substituting the given value and f of theta value as 1 by 2 pi, and taking integration I get the value 1 plus cos 2 omega naught t plus 2 theta. Then integrating with respect to minus pi to plus pi and substituting the value, I will get the value as 1. So I am 1. So this is two terms, e of 1 and another term is e of 2 omega naught t plus theta. Here I found only for e of 1. So I get integrals minus pi to plus pi 1 by 2 pi into f of theta, which means x of t takes the value as 1. So I get this value alone. So I will get 1 by 2 pi. If integrate d theta, I get only theta with respect to minus pi to plus pi. If we substitute the upper limit minus lower limit, so minus into minus plus pi, so I get 2 pi divided by 2 pi, which cancel each other. So I get the value as 1. So here I found only the first term. The next term is e of cos 2 omega naught t plus 2 theta. So which is nothing but integral minus pi to plus pi cos omega 2 omega naught t plus 2 theta into 1 by 2 pi into d theta. So if I integrate cos, I take 1 by 2 pi as constant outside. Integration of cos is nothing but sin 2 omega naught t plus 2 theta divided by 2 in the limit minus pi to plus pi. So we know if we substitute the pi to theta and minus pi to theta, so sin pi value is 0. So I get the upper limit as 0 and also lower limit as 0. So I get the whole value as 0, which means this value is 0. We already find this value as 1. So I am multiplying it. So 1 by 2, there is already 1 by 2 outside. So 1 by 2 into 1 plus 0 equal to 1 by 2. So now I am going to substitute into the variance formula. So variance formula is nothing but e of x square minus e of x the whole square. So we know the value of e of x square is 1 by 2 and e of x the whole square, the mean value already we know that it is 0. So it is equal to 1 by 2, which is nothing but the constant. So that I can easily say that x of t is a triple S process, which means it satisfies the mean condition and also the variance condition. Here is the one more problem given under Strickson stationary. Show that the random process x of t equal a cos of omega naught t plus theta is not stationary. Here itself they have given not stationary. So we are going to prove that it is also uniformly distributed random variable under 0 to pi. We already saw that minus pi to plus pi means we take the value as 1 by 2 pi. Here the interval lies between 0 to pi, which means f of theta takes the value 1 by pi. So that is the thing given here. So next we are moving to whether it is stationary or not. Here I am proving that E of x of t is equal to, we know the formula x of t f of theta d theta. X of t is the given value and f of theta value is 1 by pi. I am taking this a into 1 by pi as constant outside, and the integration of cos is nothing but sine omega t plus theta. So if I substitute the upper integral pi, it will be 0. Lower integral, I will get this value which is not equal to constant. So I can easily say that the given term random process is not stationary process. This is how we can prove the strict sense stationary process. In unit 3, we are going to see the Markov process, Markov chains. So Markov process, the definition is a random process. X of t is said to be Markov process if it satisfies the following condition. So that is, probability of x of t is less than or equal to x by x of t1 minus x. So the value of x lies between x1, x2, etc. xn, which equals probability of x of t is less than or equal to x by x of tn equal to xn. Next, definition of Markov chain. A discrete parameter Markov process is called Markov chain. So here is the first problem given under Markov chain. If the transition Markov process of a Markov chain is a 2 by 2 matrix as given here, 0, 1, 1 by 2, 1 by 2. Find the steady state distribution of the chain. So that is, first I am taking the given p value. If pi is equal to pi 1, pi 2 is the steady state distribution. They are asking for steady state distribution. So that is pi equal to pi 1, pi 2 is the steady state distribution of the chain. Then by the property of pi, so there are two conditions for pi. One is pi p equals pi. Second condition is pi 1 plus pi 2 equal 1. So pi p equal pi. So I know the value of pi is nothing but pi 1, pi 2, substituting for left and right hand side, and the value of p is nothing but the given matrix 0, 1, 1 by 2, 1 by 2. Now I am expanding my left hand side so that I get pi 1 of 0 plus pi 2 of 1 by 2. Next, pi 1 of 1 plus pi 2 of 1 by 2 is equals pi 1, pi 2. Next, here I will left only with pi half pi 2 equals pi 1. So I am comparing both left and right hand side. So this equals 0. So half pi 2 equal pi 1 and these two terms equal to pi 2. I am marking this as third equation and fourth equation. So I already know that the from second equation pi 1 plus pi 2 equals 1. I know the pi 1 value which is half pi by 2. I am substituting instead of pi 1 plus pi 2 equal to 1. So that the value will become pi 2 is equal to 2 by 3. So this is 1 by 2 pi 2, this is pi 2 plus 1 pi 2. 1 plus 1 by 2 is nothing but 3 by 2 pi 2 equal 1. So bringing this 3 by 2 to the next side, it will become 2 by 3. So my pi 2 value is 2 by 3. Now I am substituting this in equation 3. So it will change as pi 1 equal to half pi 2. Pi 2 value is nothing but 2 by 3. Cancel 2 to each other. So that I get the value pi 1 by 3 for pi 1. So pi 2 value is nothing but 2 by 3 and pi 1 value is 1 by 3. I already know that the steady state distribution of the chain is pi equal pi 1, pi 2. I am substituting for pi 1 and pi 2. This is how we can find the problem under Markov chain. Next we are going to see one problem under transition probability matrix. So here is the problem. The transition probability matrix of the Markov chain xn equal n equal 1, 2, 3 etc. having 3 states, that is 1, 2 and 3 is, here they have given the 3 by 3 matrix and the initial distribution also given. So 0.7, 0.2, 0.1. This is p power 0. So I am taking the first value of p of x naught equal 1. Second value as probability of x naught equal 2, and the third value as probability of x naught equal 3. Here is the value I have taken it. Next, we need to find probability of x2 equal 3 and probability of x3 equal to x2 equal 3, x1 equal 3, x0 equal 2. We need to find these two conditions. Let's see. For that, we need to find p square. So we know the value of p which is given in the question. So I need to find p square, which is p into p. So multiply p matrix, that is 3 by 3 matrix, for 2 times. So I get this matrix. This is the p square matrix. Now we need to find a probability of x2 equal 3, which takes the formula as summation I equal to 1, 2, 3, because this is a 3-state process. Probability of x2 equal 3 by x0 equal to I into probability of x0 equal to I. So here I am substituting for 1, 2 and 3. First, instead of I am substituting 1, that is probability x2 equal 3 by x0 equal to 1 plus into probability of x0 equal to 1. Second, I need to substitute 2. Probability of x2 equal 3 by x0 equal to 2 into probability of x0 equal to 2 plus third term, that is substitute 3 for I. So that I get x2 equal 3 by x0 equal 3 into probability of x0 equal 3. So this can be written as 1 and 3 is written as p13 power square, which is a p square matrix into probability of x0 equal to 1. So this can be written as p23 power 2 into p of x0 equal to 2. Third term is p33 the whole square, which is second term square matrix into p of x0 is equal to 3. So p of 1, 3 is nothing but in the first row, third column. So I get 0.26 and I know the value of x0 is equal to 1, which is nothing but 0.7. Next, probability of 2, 3 is second row, third column, value is 0.34 and the value of x0 equal to 2 is nothing but 0.2. Our third value p of p33, which is third row, third column, the value is 0.29 and the value of probability of x0 equal to 3 is 0.1. If I multiply all the thing and add all the thing, I get the value 0.249. Our second condition, we need to find probability x3 equal to x2 equal 3, x1 equal 3 and x0 equal 2. So this is such a large formula, which means we need to combine first two thing and keep the remaining thing. Next we need to club first three thing and keep the remaining thing. See here, probability of 3 to power 1. So the remaining term which is inside the bracket. Next we will see p32, p33, p23 into probability of x0, that is the last term. We know the value of p of x02 is nothing but 0.2. So similarly in the given matrix, this is p power 1. So I will take the third row, second column, it is 0.3. Third row, third column, it is for 3, 2 is 0.4, next is 0.3, next is 0.2. If I multiply all those things, I get the value 0.0048. This is how we can find the values in Markov process and Markov chains. Here is the one more problem given, the training process of two-state Markov chain. If it train, it is considered to be state 0. If it does not train, the chain is in staple 1. The Markov chain is defined in the 2 by 2 matrix. We need to find that it will rain for 3 days from today, assuming that it is raining today. Find also the unconditional probability that it will rain after 3 days, with the initial probability state. So first I am taking the given matrix, that is P matrix. In this we need to find P square, that is P into P. Next we need to find P cube so that we get the another matrix. So first thing we need to find, if it rains, the probability distribution for today is 1, 0. So that is probability after 2 days, that is 1, 0 into the P cube matrix, which means total 3 days. So I am taking the P cube matrix and multiply the row and column and again the value with the column. So I get this value. Next we need to find P power 0, which is nothing but 0.06 after 3 days. So I am taking the P power 0 value into P cube value. So multiply all those things. So I get the answer 0.3376. Thank you all for the patience listening. Okay, we saw the strict sense stationary. Now we are going to see the wide sense stationary, which can also be written as WSS. Okay, so if it is WSS, mean it should satisfy two conditions. One is E of x of t equal constant, that is mean value equal constant. Then R of T1, T2, which is nothing but the autocorrelation value, should equal to a function of T1 minus T2, which means the last value should equal to T1 minus T2. Now we are going to see some problem under wide sense stationary. Here is the first problem, which states that show that the random process x of t equal a cos omega t plus theta is wide sense stationary if a and omega are constant and theta is uniformly distributed random variable in the region 0 to 2 pi. We already know that if the function is uniformly distributed, means the value of f of theta equals 1 by 2 pi. So that is the value given here. So if the interval is 0 to 2 pi, means f of theta takes the value 1 by 2 pi. So we need to prove that the given function is wide sense stationary, which means it should satisfy two conditions. By the definition of wide sense stationary, so mean value should equal to constant and the autocorrelation value is equal to a function of t1 minus t2. First I am going to prove the mean value is equal to constant or not. So first I am taking E of x of t is equal minus integral to plus integral minus infinity to plus infinity x of t f of theta d theta. So x of t is nothing but the given value, that is a cos omega t plus theta, and the f of theta value is nothing but 1 by 2 pi. So here I am substituting. So 1 by 2 pi is constant and also a is constant and I am taking it out. So the value of thing is lies between 0 to 2 pi into cos of omega t plus theta. Actually I take the f of theta 1 by 2 pi as constant outside. Now we are going to integrate it with respect to theta. So sin cos theta will become sin of omega t plus theta with the limit from 0 to 2 pi. So which is nothing but a by 2 pi of, I am substituting the upper limit for theta, sin omega t plus 2 pi. So lower integral sin 0 is 0 only. We already know that the sin 2 pi values and all 0. So 0 into anything is equal 0. So I can easily say that the mean value is equal to constant. Next we need to prove the autocorrelation value, that is R of t1, t2 equal E of x of t1 into x of t2. So we know the x of t value. Instead of t, I am substituting t1 and t2. Here there are 2a, so I am taking it as a square. So this is cos a plus b into cos a minus b, which can be written as so that is a formula for cos a in plus cos b, cos a into cos b equal cos a plus b into cos a minus b. So I am substituting this term here. See here I am taking a square which is 2 cos a cos b equal cos a plus b into cos a minus b. I am bringing this 2 to the next side, so it will be 1 by 2. So a square is inside the bracket, so I can take it as a square by 2 into e of a plus b. So which means cos of omega t plus theta plus omega t2 plus theta. So there are 2 theta here. So which can be written as 2 theta and omega t1, omega t2. So I can take omega as constant out. So t1 plus t2 will remain in the bracket. Similarly for cos a minus b, I get the value a square by 2 cos omega of t1 minus t2. So if we solve for this thing, I get the value as 0. So I will remain with the thing a square by 2 cos of omega t1 minus t2, which is nothing but a function of t1 minus t2. Hence I can easily say that the mean value equal to constant and autocorrelation also equal to a function of t1 minus t2. Hence x of t is a wide sense stationary process. Now we are moving to the second problem. If x of t equal a cos lambda t plus b sin lambda t, where a and b are two independent normal random variable with a mean value equals 0, that is e of a and e of b equals 0, then e of a square equal e of b square equal to sigma square, where lambda is a constant. Prove that x of t is strict sense stationary of order 2. We are asking for order 2. Now see how to solve this. I am taking the given x of t value and e of a and e of b is 0. Here already they have mentioned independent. So e of ab can be written as e of a into e of b. Both value equals 0. So e of ab also equals 0. And also given term e of a square equals sigma square. So I am taking it as k. And also e of b square equal to sigma square, I am taking it as k. Now we need to prove it is a wide sense stationary process, which means mean condition equal to constant and autocorrelation value equals a function of t1 minus t2. Our first condition, that is mean value e of x of t equal e of the x of t value is a cos lambda t plus b sin lambda t. So I am multiplying e inside the bracket for a and e of b. We already know that e of a and e of b value is 0. So mean value is equal to 0. So the first condition of wide sense stationary is proved. Second condition, autocorrelation. We know the formula e of x of t1, x of t2. In the question substitute t1 and t2. Next there is I am multiplying all the 4 terms, that is a into a square cos lambda t1 into cos lambda t2. Then b, that is b square sin lambda t1 into sin lambda t2. Then a b cos lambda t1 into sin lambda t2. Next b a, which can also be written as a b. So I am closing the bracket, which means I am taking it as ab. In both the terms ab are common, so I am taking it out. So the remaining term is sin lambda t1 into cos lambda t2. Now I am substituting e of a square, second e of b square, then e of ab. I already know the value of e of a square is nothing but, e of a square value is k and e of b square value is k and e of ab value is 0. So I am omitting the third term and the first and second term will become taking k as constant and the remaining term will be in the bracket. So 2 k terms are there. So I am taking k as a common. So cos a cos b plus sin a sin b. Formula is cos a minus b. So which can be written as a function of t1 minus t2. Hence both the conditions are satisfied. We can easily say that the given process is wide sense stationary. Now we are moving to the third problem. Consider a random process x of t defined by n of t u cos t plus v plus 1 into sin t, where u and v are independent random variable for which e of u and e of v equals 0, e of u square and e of v square equals 1, x of t is WSS, your answer they are asking. So now I am taking the given term x of t and also the given e of u and e of v equals 0. Then e of u square and e of v square equal 1. And also they have given it is independent u and v, which means e of uv equal e of u into e of v. So both the values are equal, which means e of uv also equal to 0. Now I am proving mean value, that is e of x of t is nothing but e of, here I am substituting the x of t value, this is u. Now I am substituting e inside the bracket, that is e of u, next e of v, next there is a 1, no need to write e of 1, so just to simply write sin t alone. We know e of u value also 0, e of v value also 0, so I left with sin t. So the value of mean is equal to sin t, which is not equal to a constant. Here itself I can easily say that x of t is not void in stationary. If the first condition is not satisfied for void in stationary, means we need not to prove the second condition, that is autocorrelation value. This itself enough.